This is question number 8 from the 3.5 MyLab math homework on implicit differentiation. So in this problem, we're given an equation and we're being told to use implicit differentiation to find y prime. So when you see implicit differentiation, that means you have to use the equation as it was written. You're not going to use any algebra to rearrange things or simplify before you start the derivative. You have to use what was given to you. And they're asking us to find y prime. Now on a quiz or a test, I'll give you this extra notation here that shows that y is a function of x, because we need to slow our brains down when we see these letters in the equation in a minute and ask ourselves, okay, is this letter representing a variable or is this letter representing a function? And with this extra notation, it's easier to see that your input variable is the x. So when you see an x prime, if you take the derivative of a plain old variable, it's going to be a 1. And then you can see that your y is a function of x. So y is a function. That means if you find y prime, the derivative is not 1. You're just going to record y prime. Okay, so let's go ahead and take our derivative implicitly. So we're going to start by taking the derivative of the left-hand side and the derivative of the right-hand side. And we'll go piece by piece. Now, the first term here is x squared times y. X squared times y. There's two different letters. The letter x is acting like a variable. So x is acting like a variable. X is a variable. That means when I take the derivative of x, it's just 1. But y is acting as a function. So y is a function. Okay, and they're side by side multiplying. That means we need product rule. First and second. So if my first is x squared, when I take the derivative of the first, it's just going to be 2x times the derivative of the base, which is just a 1, so I don't have to write it. That's just normal power rule. And then for the second function, it's just a y, so the derivative of the second function is y prime. And y prime, again, is not equal to 1, so I'm just going to record that as y prime. And then we'll use our product rule over here. So I'm going to do first times derivative of the second plus second times derivative of the first. And then I'll go to the next term, or subtracting 4x squared. Again, I'm just going to use my power rule here. I don't really need chain rule because the base is a plain old x. So using my power rule, I'm going to end up getting -8. Rewrite my base, x. Decrease the exponent by 1. An understood exponent of 1 doesn't get written. And technically multiply by the derivative of the base, which is also 1. So I just get 8x there. And then on the other side of the equation, I have to take the derivative. I have to take derivative of every single piece. It's a constant, 0, and the derivative of a constant is just 0. So that's my raw derivative here. I can clean it up a little bit. I mean, really, the only thing I could do is rearrange the order of the multiplication in that middle term. So I have x squared times y prime plus 2xy minus 8x equals 0. And we're trying to get y prime alone, so all I need to do is subtract the 2xy from both sides and add the 8x to both sides. Okay, that would give me my x squared. Oh, yes, that would give me my x squared y prime equals to -2xy plus 8x. And you could flip-flop the order on those two. You could write 8x first minus 2xy second if you wanted to. And then, yeah, now we just have to divide by x squared. Okay, so that's our y prime. Now your y prime could look a little different if you rearrange things in the opposite order, but they'd be equivalent. And then the last thing we're being asked to do here is just to evaluate this y prime at the point, let's see, 2, 4. So we're going to evaluate that at the point 2, 4. That just means I'm going to plug in a 2 everywhere I see an x, and I'm going to plug in a 4 everywhere I see a y. Okay, we can do that. So that's going to be -2 times 2 times 4 plus 8 times 2, and all of that's going to be over 2 squared. Okay, so we'll just plug that into our calculator. Or I guess, these numbers are small enough we can do in our head. So let's see. When I multiply this first group together, that's going to be negative 16 plus, I multiply the second group together. Oh, that's positive 16. So in the numerator, I'm going to end up with a 0. And in the denominator, 2 squared is 4. So 0 divided by 4 is just 0. Okay.